Okay, so this is Perms and Comms lesson number 1 for Rob Shaughnessy's class. Standard disclaimer here, the videos are no substitute for class attendance. Please just pause and read it. Basically, this is just a quick tutorial to guide you through some of the basics of the lesson. So if you have any questions, please contact me or contact your math teacher. Going along with this is Perms and Comms. This is the first unit of the whole course. Now, what we've got to do is we've got to get started. Now, usually what I do is I walk in, and if you were in class, I would have walked in and said, okay, let's take a look at this a little bit more. Let's take a look at some situations. And I would have come to you and said something along the lines of, hey, I got a buddy coming over and I need some help. I am going to make them dinner for everybody. This is all just a wonderful thing that we're going to do. And the intention here is now I want to kind of make it as little work as possible. So I've got a friend coming over. I got 3 types of noodles in my cupboard. I've got spaghetti, I've got rotini, and I've got corkscrew pasta. Okay, and that's what's in my cupboard right now. And anything else, it just isn't in there. And so I say, well, what can I do? Well, I've also got sauces. Now, I don't want to make a bunch of different sauces for everybody. I've got a meat sauce. I've got a marinara sauce. It's really actually nice. I do garlic chicken marinara kind of thing. It's really good. I like it, but it takes a little bit of effort. I also can do, and I hate them, but I also can do Alfredo sauces. Okay, my kids like them. I make them on occasion, but truly, really, I'm not a big fan of those. Also, too, just so you're aware, if I look at what's in my cupboard, I've got a canned thing of sauce. I could just heat that up, put it in the microwave, put it in a bowl, cover it for 90 seconds, and there we go, I'm done. Now, if I make the same thing for everybody, I could have spaghetti and meat sauce, spaghetti and marinara, spaghetti and Alfredo, or spaghetti and canned sauce. Same thing goes with rotini. Okay, if I make the same thing, I've got a meat, I've got a marinara, I've got an Alfredo, and I've got a canned sauce option for each of those. As well as in the corkscrew pasta, I've got 4 options for sauces there. The meat, the marinara, the Alfredo, or the canned sauce. Now, when I start to look at this, we say, okay, so this is what I'm going to do. So I usually end up chatting with the kids. What do you think I should do? And so there's always an opinion somewhere along the line. Somebody wants one, doesn't want the other, vice versa. But then I say, well, how many options do I have? Spaghetti and meat, spaghetti marinara. And if I count them on the opposite side of my tree diagram here, I can see that there are 12 options. Okay? And so we just notice that. Okay, there's 12 options. Now, the other thing, hopefully somebody notices in class is, well, if there's 3 types of noodles, and I recognize the typo, 4 types of possible sauces, what do I know? Well, I know 3 times 4 is 12, and I wonder if that's a coincidence. And I'm here to tell you that no, it's not a coincidence. But nonetheless, we just leave that. Then I go on and I start talking about, well, what else can I do? Well, let's talk about a family here with 3 kids. Okay, how many different possible distributions of the gender are there? And so if I've got 3 kids, I've got kid 1, I've got kid 2, and I've got kid 3. Okay, and in each case, what I've got is different possibilities. Now, really, the only possibilities, it doesn't say it in the question, but stop, think, what do you know about kids? Well, it's a boy or a girl. That's what you're going to get. I know there are exceptions, but it's a boy or a girl. Okay, so the first kid could be a boy or a girl. Now, in my case, it was a bouncing baby boy. In various other people's cases, it's a girl. Nonetheless, you've got this first kid. Then you go around to get the second kid. Well, there are 2 options for the second kid. The second kid could be a boy or a girl. Surprise. Again, if the first kid was a girl, then you could have a boy or a girl again. And so you just keep going. Now, as you go on, there's always 2 more possibilities for that next kid. The third kid, you have a boy, then a younger brother, and then you could have a boy or a girl for that third kid. Ditto for this situation here. A boy, then a little girl, then you've got either a boy or a girl for that third kid. And so on and so forth. You've got 4 choices, boy or a girl. 4 choices, boy or a girl. Okay? And so you look at that and say, well, okay, those are our options. And think about your family, especially if you have three children in your family. What are the distributions? Is the oldest a boy or is the oldest a girl? And so there are a variety of different options here. Now the boy, 3 boys, okay, some families are like that, boy, a girl, etc. There are 8 options or 8 possibilities. Okay, and they say, well, how does that tie in? Well, really what you've got is you've got kid 1, I'm just going to put 1, kid 2, and kid 3. And in each option, kid 1, there are 2 possibilities for kid 1. There are 2 possibilities for kid 2. There are 2 possibilities for kid 3. And if I take those 2 times 2 times 2, hey, that's 8. And so people start to say, I wonder if that's a coincidence. And no, it's not. And that's where we lead to the fundamental counting principle. Okay, the fundamental counting principle, and once again, typo. Okay, I dictated these, and Siri doesn't always get the right meaning, and I just didn't notice till after I'd printed. Fundamental counting principle is you're faced with a series of choices, and you've got to take a choice and pick one thing for each of those choices. In this case here, I had a choice for kid 1, I had a choice for kid 2, I had a choice for kid 3. That was a little random, but nonetheless, that's the idea. Here I've got a choice for noodle and a choice for sauce. So I've got one thing in each of those choices. If you're trying to do that, you're still arranging them. You're still putting them first kid, second kid, third kid, etc. We just divide the situation into individual choices or blanks and multiply the options of each choice together. So that's what we end up doing. If I look at this question here, a license plate consists of 3 letters followed by 4 digits. Well, I've got a letter choice, then a letter choice, then a letter choice, then a number choice, and a number choice, and a number choice, and a number choice. So I've got those. Now keep in mind what I said, letter and a letter and a letter and a number and a number and a number and a number. I'm using the word and deliberately. And in mathematical circles tends to mean multiply. So that's what I'm doing, as I'm multiplying each of these, and this makes sense. If I'm looking at the license plates, all 26 letters are possible, all 10 digits are used. Now, I know that's not exactly realistic. There are situations that they don't use, there are letters that they don't use, but let's forget about that for a sec. There are 26 choices for that blank. Okay, 26 letters to choose from. I'm allowed to, do everything again. So this next one here, whatever letter I put first, I can put 26 other letters there. And I can put 26 other letters there. And then I can put 10 digits and 10 digits and 10 digits and 10 digits. And ultimately, when I look at this, then I say, okay, well, how many choices do I have? And I go and crunch the numbers. Now I'm going to cheat because I've got the numbers here in front of me. I just didn't have them open. That is 175,760,000 possibilities. Okay, so there are 175,760,000 possible license plates in this particular situation. Now, in actuality, it's actually less. Why? There are letters they don't tend to use, or at least they don't commonly use. I and O aren't commonly used. I because it looks like a 1, O because it looks like a 0. Also, too, there are situations that they don't use. I mean, crunch the numbers or, try to work it out. Come up with a 3-letter word that you don't think would be on a license plate. There you go. That's one that they wouldn't use. They just wouldn't put that there. So it's actually less than that, but you've got this basic idea. Now, going with this idea of license plates, you can just crunch the numbers and get all sorts of different situations. If I take this here and I go and try to take license plates with no repetitions. In fact, I think I've got that. How many license plates are possible if you're not allowed to repeat characters? Well, you go with the basic idea. What's a license plate? It's a letter, then a letter, and a letter, then a number, and a number, and a number, and a number. If you're not allowed to repeat characters, then you've got 26 choices for that first letter. Then you've got 25 choices for the next letter, because whichever letter you used, you're not allowed to use it again. So there's only 25 to choose from. Continuing with that idea, this third letter, I've used 1, I've used 2, so I've only got 24 left. When it comes to the digits, well, there are 10 digits to start with, but then it goes continuing down. I used 1, so it's 9. I used another one, so it's 8. I used another one, so it's 7. And so I worked this out. Now, if I work this number out, it's 78,624,000 plates if you're not allowed to repeat characters. Okay? And as you think about this makes sense too, because the first number was quite a bit larger than this. As you get more and more particular, as you get more and more restrictive, you have fewer and fewer options. This next one here, how many license plates are possible? I'm going to try to focus this again because it doesn't look very good. How many license plates are possible that end with an odd number if repetitions are allowed? Well, okay, same idea. 3 letters, 4 numbers. Okay, and I look at this. Now, usually the best option is to start with something that's the most restrictive. In this case, ending in an odd number is the most restrictive situation. So I'm going to look at that last digit. How many choices do I have if that has to be an odd? Well, there are 5. A 1, a 3, a 5, a 7, or a 9. So there are only 5 choices there. Now, I didn't start at the beginning, but I'm starting with the most restrictive restriction. After that, I've got repetitions are allowed, so I can go to town from this point on. There are 26 letters in each blank, and there are 10 numbers in each of these 3 blanks. The only issue is that last one. Keeping in mind I multiply them all together, and I'm going to get that there are 87,880,000 plates. Okay, so there we go. They ended in an odd number. That's simple. If I look at how many license plates are possible that end in an odd number if you're not allowed to repeat characters, well, it's the same basic idea. So here I've got a couple different restrictions that I have to consider. 3 letters, 4 numbers. It's got to end in an odd number, and you're not allowed to repeat. So I'm going to start with, the odd number is kind of the hardest one to work with, so I'm going to start there. That has to be 5 for the same reason as it was before. But now when I go, I'm not allowed to repeat. So I'm going to continue with the numbers for a moment. There's no repetitions allowed. For that first number blank, instead of having 10 choices, I've got 9. The reason I have 9 is because whichever odd number I put there, it's gone, and I don't have that opportunity here. Now, for this third number here, I've got 8 more choices. I've used 1 here, and I stuck an odd one there, and that's what I've got. Here there are 7 choices, same idea. I've used 1, 2, 3 already. Out of the 10 there are 7 left. Now with the letters, one of these blanks I've got 26 choices for. But if I'm not allowed to repeat, then there's 25 choices for the next letter, and then 24 choices for the last letter. And so I look at these. Now this is fairly restricted. It's got to be odd. There's no repetitions allowed. So I've got a whole variety of restrictions going on here. You'd expect this number to be a little bit lower, and it is 39,312,000. Okay, so you've got that. That's your number there. And so you go with that. Now this is the fundamental counting principle. In each case, I'm finding a series of blanks, and I'm multiplying because I've got to do this first blank and this second blank and this third blank, and so on and so forth. If I look at this particular case here, Maggie's bank allowed a 4-digit PIN for her bank card, but it didn't allow repetitions. Security has become a concern, and the rules have changed, and now she's allowed to repeat digits. So there are 2 cases here. There was the before, and then there was the after. If I look at the before, and there's not a lot of room. Before, I've got the 4 blanks, and I wasn't allowed to repeat, so I had 10 choices for that first number, and then 9 choices, and then 8 choices, and then 7 choices, and that's what I've got for my choices. And 10 times 9 times 8 times 7, before, I've got 5,040 different possible PIN numbers. Now that they've changed it, the after, I've still got the 4 digits. But I am allowed to repeat. So I've got 10 choices, and then 10 choices, and then 10 choices, and then 10 choices. So now, or this after situation, I have 10,000 possible pins. So I've done 2 questions right now, but now I'm going to go back, and the key thing with perms and coms, read it. Maggie's bank allowed a 4-digit PIN number for her bank card, but with no repetitions. Security's become a concern, rules have changed, and now she's allowed to repeat. How many more PIN numbers are possible? That word there is key. How many more? There are 10,000 now, 5,040 before. So if I do 10,000 minus 5,040, I'm going to get my answer. And if I do that, it's 4,960 more. That's how many more you can do on the new rules. Okay, and so that's done. Now you can do all sorts of things with pin numbers. Pin numbers are another one. I'm going to skip this example for a sec. I'm just going to go off and talk about a few other things. How many digits, so I can do other examples, and I'm just going to make sure that shows up. How many 4-digit pins are possible if the first and the last digit must be odd, but no restrictions but restrictions are allowed. Repetitions are allowed. I can't say this. Okay, so in this case here I've got a few other restrictions. I've got a whole variety. Keeping in mind it's a 4-digit pin. This, 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 and this. Now, if the first and the last digit must be odd, but I'm allowed to repeat, well, I've got 5 choices for that odd and 5 choices for that odd. The reason they're the same is because I'm allowed to repeat the digit. So it doesn't matter what number I put in front, I can still use it again at the end. Now, those are the only restrictions. So now I can go, well, there's 10 choices for that digit and 10 choices for that digit. And so what I end up with is 2,500 possible pins. That's how many I can do if it's a 4-digit pin starting and ending with an odd number. If I do the same thing, okay, same as above, but with no repetitions. Okay, you can tell I'm a math teacher, not a language teacher. Same as above, but with no repetitions. Well, I've got 4 blanks. Okay, in one of them I've got 5 choices for that odd number. Okay, but then I've only got 4 choices for the last odd number because I'm not allowed to repeat. And so in this situation here, whatever's done, I've got 5 choices for that first one, 4 choices for the second one. Once that is done, then I have 8 more choices because I've used 2 digits already and I'm not allowed to repeat. And then 7 more choices here because I've used this digit, this digit, this digit. So I've used 3, I've got 7 left. Okay, so 5 times 8 times 7 times 4. Okay, that's what I end up with. But that's if I put that digit first. But you know, the nice part is it doesn't really matter because if I put the 5 here and the 4 there, it's still the same thing. So what I'm going to do is 5 times 8 times 7 times 4, and I'm going to use my calculator here for a second. Looking at that, I've got 1,120 different possibilities. So I've got no repetitions. If I do that, I've only got 1,120. Okay, everything else has a repetition in it, so I'm allowed to do that. Okay, if I look here with, actually I'm going to go back to the example here. Looking at what I've got here, how many 4-digit pins are possible if we don't allow repetitions? And the number of the pin, once again this is dictating to Siri, I'm sorry, of the pin must be larger than 8,000. Well, I look at this here and I say, okay, it's got to be larger than 8,000. So if I look at this particular situation, there are 4 particular blanks. Now if it's got to be larger than 8,000, this first blank has to be an 8 or a 9. Can't be anything else. If I put a 7 here, it's not going to be larger than 8,000. It's just not. And anything else, 6, 5, 4, 3, 2, 1, or 0, if I put it here, it's not larger than 8,000. So I've only got 2 choices for that blank. Next, okay, no repetitions. Don't allow repetitions. Okay, so I've put one, either an 8 or 9, but I put it in front. So in this particular situation now, I've got 9 more numbers that I can choose from for that blank. And then 8 more numbers that I can put forth for that blank. And then 7 more numbers that I can put forth for that blank. Okay, there are no repetitions. Okay, So if there are no repetitions, 2 times 9 times 8 times 7. And if I go and do that, and sorry I don't have that number in front of me, there's 1,008 possibilities. Okay, that's the 4-digit pins, no repetition, so you can see I'm reducing each time, and it must be larger than 8,000, so I have to start with something bigger than, like 8 or bigger, 8, 9, 10. I can start with 8 because if I put something else here, 8, I'm not allowed to repeat, so even if I put the 0 here, I'm putting something that's other than 0 here, so it's going to be bigger. So I'm all set and done. Okay. This next one here, for phone numbers in Alberta, there are three possible area codes and 7 digits in each phone number. How many phone numbers are possible over these 3 area codes? Now, in all honesty, I've got an area code. I'm going to put a blank for AC, and I've got 7 other blanks. So I've got that. There are 3 choices of area code. I'm done. Now, if I don't think about it too much, and this is kind of a little vague, so sometimes you end up overthinking it or underthinking it or whatever. If I don't think about it too much, I've got 10 choices in each of these blanks. Okay, and I do that, it's going to be 30 million possible phone numbers. Okay. But then I can start to think about this. The other way of looking at this, or I could think, well, I've got 3 choices of area code. That's all well and good, but I know something about phone numbers. And I know that a phone number doesn't start with a 0, because then I'm going to get the operator, and it doesn't start with a 1, because then I'm going to be dialing long distance. So I know it doesn't start with a 0 or a 1. And if it doesn't start with a 0 or a 1, there are only 8 possibilities here. Now I'm still allowed to repeat the numbers, the digits, so there are 10 choices for the rest of the way. But this is just because I don't start in a 0 or a 1. I'm going to get a completely different answer here. This particular answer here, I'm going to get, I think it's 24, and then 6 zeros. So there are 24 million possible numbers in this case. Which one is right? Well, both. This question is a little bit vague, and so because of that I'm forced to make some different assumptions. One of the assumptions I'm making is that I can't put a 0 or a 1 here, so that makes this 8. If I miss that, I put a 10 here. I still understand it. I'm getting 2 different answers, depending on how much other information I know. Now, going along with the fundamental counting principle is the idea of factorials. Now, factorials get a little bit more complicated, but they're not hard. Okay, factorial. And I'm just going to write this out. A factorial is something that's kind of particular. If I look at 5 factorial, what that means, it's a math operation. 5 factorial, purely because somebody decided this somewhere along the line, 5 with an exclamation mark behind it does not mean 5 and you get to shout it out really loud. It just means 5 times 4 times 3 times 2 times 1, and then you stop. 5 factorial is 5 times 4 times 3 times 2 times 1. That works out to be 120. 4 factorial, same idea. It's 4 times 3 times 2 times 1, which is going to be 24. I had to think about that. Okay, 3 factorial, same idea. It's 3 times 2 times 1, or it's 6. 2 factorial is 2 times 1, which is 2. 1 factorial is 1. Times none, or times there's no other multiplication, so it's just 1. And you can have larger factorials too, 6, 7, 26, whatever else you want. Okay? But going through with this, when you have factorials, you've got this, basically you just multiply every number going down one at a time until you get to 1, and then you stop. Now, here's the weird part. The other one we need is 0 factorial. Now, to see 0 factorial, watch what's going on. I start up higher. To get from 5 factorial to 4 factorial, what I'm going to do is 4 factorial is 5 factorial divided by 5. 5 factorial divided by 5. If I take 120, divide it by 5, I'm going to get 24. Okay, continuing down. 3 factorial is 4 factorial divided by 4. 2 factorial, continuing the pattern, is 3 factorial divided by 3. If I take 6 divided by 3, I get 2. 1 factorial is 2 factorial divided by 2. So we're all said and done. Now if I continue the pattern, what ends up happening is 0 factorial would be 1 factorial divided by 1. 1 factorial is 1. 1 divided by 1 is 1. So 0 factorial is 1. By this pattern, okay? This is just why 0 factorial is 1. By the pattern, that's what happens. Now, can you do negative factorials? The answer is no. Watch what happens. If I start to go next, negative 1 factorial, it would be 0 factorial divided by 0. So 0 factorial is 1. 1 divided by 0. I am not allowed to do. It's not possible. It's empty set. Okay, empty set, the 0 with the slash through. Okay, I'll write that here because that'll come up later. Empty set. Okay, so there's just no possibilities. So this cannot be done. Okay, so it cannot be done. It's just not a possibility. This basically boils down to there are no negative factorials. That's the key thing there. There are just absolutely no negative factorials because you get this 0 factorial divided by 0. Empty set. Okay, it doesn't make any sense. And as you continue down, you've got something that doesn't make any sense divided by something else that doesn't make any sense. And you might as well just kind of keep going. So you've got this sort of idea. How do factorials come up with the fundamental Browning principle? Well, if remember that toddler question, we were arranging 5 books in order. Okay, so we're arranging them in order. We've got the 5 books, and so how many possibilities, how many arrangements are possible? Okay, so you say, well, I've got the 5 blanks, 1, 2, 3, 4, 5. I've got 5 choices for that first book, 4 choices for the next, 3 choices for the next, 2, and then 1. And if I work that out, 5 choices for the first book times 4 choices, so on and so forth, I could say, especially in a multiple choice, that that's just 5 factorial. The answer is 120. Okay, but 5 factorial would be another appropriate way of kind of figuring it out. So you're watching for the idea of factorials. The other things that come with this is you can do questions like this. Really easy. Calculate 26 factorial divided by 24 factorial without a calculator. Okay, so I don't have a calculator. I can multiply, but I don't have a calculator. And I am not going to go by hand and figure out 26 times 25 times 24 times 23 times 22 and so on and so forth. But I do know that this is going to be 26 times 25 times 24 all the way down to 1. So I'm just going to stop and say I don't want to write anymore. I'm going to put the factorial there. 26 times 25 times 24 factorial. And if I have that all divided by 24 factorial, well, if I multiply by 24 factorial in the top and divide by 24 factorial in the bottom, I don't even need to consider it, so those just cancel. And so what I end up with is 26 times 25. Now, yes, that takes a little bit of work. There's no question there. But this multiplication I can do by hand. 26 times 25, depending on how you do it, 5 times 6 is 30, carry the 3. 5 times 2 is 10, plus 3 is 13. Magic 0. 2 times 6 is 12, carry the 1. 2 times 2 is 4, plus 1 is 5. Go on. I'm going to get 650. So that's what this is going to be. And I did it without the calculator. Now admittedly these are kind of tricks that I sometimes use when I'm working at the front of a class. So I can go do that. How do I do it using the calculator? Well, here's my handy dandy TI-84. Turn it on, there's some calculations there. If I want to do 5 factorial, 5, I can put in the digit, okay, and then I push the math key. Now the math key is this one here. So I push math, and I get to this window, and I scroll to the right until I'm in the probability window, and that thing there, that's the exclamation mark. So I just go down, say option 4, pull it out. Now I've got 5 factorial, and if I hit enter, it's going to do 5 times 4 times 3 times 2 times 1, or 120. Now the light's kind of getting involved here, but nonetheless that's the idea. And I can do any factorial. 4 factorial is 24. Okay, if I do the 26 factorial, the one we just did, divided by 24 factorial, provided the calculator can do numbers this high, that's going to tell me it's 650, which is what I already calculated anyway. But that's how I use factorials in the calculator. Now, last but certainly not least is an example, and I'm just going to go back to the typed pages. An example like this. We're making fruit salad. I'm going to try to focus this, see if that makes a difference again. It doesn't make a lot of difference. I'm making fruit salad, and I have to have at least some fruit. If I don't have any fruit, I don't have fruit salad. I have a bowl. Okay? There is the possibility of using up to 3 apples, up to 2 peaches, and up to 4 kiwis. See? That's what I can use. How many possible fruit salads can be made? Now, different ratios, it's a slightly different fruit salad. We all know we've had fruit salads where, oh, there's a bunch of pears, or oh, there's a bunch of kiwi, and I'm allergic to kiwi or whatever. So the different ratios make a slightly different fruit salad. So in this particular situation, I'm looking at it, I've got a choice of apples, a choice of peaches, and a choice of kiwis. So I'm sitting here and I'm just about ready to go, and I say, oh, you know what, this is almost done. I can use up to 3 apples, so I can use 1 apple or 2 apples or 3 apples, and I'm almost ready to do, but that's not my only possibility. 1 apple, 2 apple, 3 apples, or I may say to heck with the apples. I don't want any apples at all. So if I have 0, 1, 2, or 3 apples, I have 4 choices in my apple basket. Going along with that, and by extension, peaches. I have 2 peaches. I can use 1 or 2 peaches, but I could also use 0 peaches. So 0, 1, or 2 gives me 3 choices for peaches. When it comes to kiwis, I have 4 kiwis. I can use 0, 1, 2, 3, or 4 kiwis. That's 5 possible choices. And I work that out, and that's going to be 60. Now I'm almost ready to go. This idea of, having to count the 0 possibility comes up occasionally. If I'm talking about somebody getting dressed, I may look at, well, he has to wear pants, he has to wear a shirt, but he doesn't have to wear a hat. So he has 5 hats, but there are 6 choices for hat, because he could go hatless. That sort of idea. And so once you've got that under your belt, here's where this one comes a little bit more complicated. Because what this particular situation, that 60 number includes no apples, no peaches, no kiwis. And that has been counted, the no apples, no peaches, no kiwis. That has been counted in the 60. And it's not a fruit salad, that's just a bowl. We talked about that before. So I'm going to subtract the 1. Why 1? Because there's one situation where I have no apples, no peaches, and no kiwis. So there's one example left. So what that means is there are 59 possible fruit salad recipes that I can use. Okay? And I'm all said and done. This is that first lesson. This is that first unit. Hopefully this is helpful to you. If you're having any questions, please feel free to come and contact a friend or contact myself. These notes that you're seeing me generate here are available on a web. And otherwise, have a marvelous day. Thank you.